Recording. Have you ever wondered why your high availability solutions are constantly encountering issues after issues and started wondering maybe your initial HA design is actually broken? This week on the Practical SQL Server HA show, I will be covering this very topic. My name is Edwin Sarmiento, and welcome to this episode of the Practical SQL Server HA show. The purpose of this show is to share tips and tricks, lessons learned, insights regarding high availability and or disaster recovery solutions, particularly on Microsoft Data Platform solutions, although I do focus on always on availability groups because Microsoft, that's kind of like Microsoft's flagship feature for on-premises data platform solutions, specifically SQL Server. And for today's topic, I want to talk about how your initial HA design is actually broken, and the reason why you're encountering issues after issues after issues. And I want to talk about this because there are cases where you are given the responsibility to take care of a high availability solution. Somebody built it for you, but then there was no handoff, there was no hand holding. Maybe it was a senior DBA who happened to move on to a new job opportunity, or somebody built it for you like a managed services provider or an external consultant. They built it for you, and then again, no proper handoff, no hand holding. They just happened to give it to you, and you got no clue why what was supposed to be highly available is not highly available. I had this post on LinkedIn the other day where I was pointing out a couple of things about the term always on. And if you've watched a couple of the videos that I've posted in the past, you may have noticed how sometimes I make fun of the term always on, right? Because you kind of instinctively think that it is always on, like 24/7 by 365. It never goes offline, but in reality, well, it's made by humans, so it will eventually break. It's not a question of if, it's a question of when. So the term always on happens to be like, ends up becoming the butt of all jokes because sometimes it's almost on. But the technology is solid, right? The technology is solid. It's not designed, but it was written properly. But however, there are cases when it doesn't do what it's supposed to do. Hence, the topic of today's episode: why your initial HA design is actually broken. Grab your pen and paper, start taking notes. Here's the first reason, okay? First reason why your HA design is actually broken is you're simply focusing on just the database, just the database. And of course, as a database administrator or sometimes a sysadmin who happens to be taking care of your SQL Server databases, when you are given the responsibility to manage something like an always-on availability group or any kind of high availability solution for databases, the focus is just on the database, without realizing there's an entire ecosystem, okay, that has to be a part of it. And again, it's tempting to just look at the database because that's exactly what you need to focus on. Like you're given the responsibility to manage a high availability solution for your databases. And of course, this is just the only thing that I have to worry about, especially when you're in large organizations where there's segregation of duties. And so if you're part of the database team, you're given the responsibility just for the databases. So your focus is simply on the database, without realizing there's an entire ecosystem that should be a part of your high availability solution. The database is just one piece of it. You're looking at the app, you're looking at environments around it, which is the second point. But the problem with designing high availability solutions with just the database in mind is you've been blindsided by the fact that there's other things that connect to this. Okay, the the phrase that I usually refer to this is the superhero database administrator, which means you can manage your high availability solution for your database. You can fail it over, you can move it around. But just because you can perform administration for your highly available databases doesn't mean the entire ecosystem around it is also the same. I mean, what's the point of building a highly available database if your apps are not designed to take advantage of high availability? It's one of those cases where, because we're so focused on one thing, we forget that this is just one piece of an entire puzzle, right? Again, just focusing on the databases. In the case of an always-on availability group, it's one of many databases, okay? In an availability group, and your availability group sits on top of SQL Server, of course, and your availability group sits on top of Windows Server failover clustering, and your Windows Server failover clustering sits on top of Windows, and your Windows operating system, Windows Server operating system, sits on top of a hardware or maybe a virtual machine. So there's more to it than simply just database. Okay, but again, the thing here is the design of the HA solution simply focuses on just the database, without realizing there are other things that are part of the entire ecosystem, which leads me to the second point. And I'm trying to connect the dots here, because the database is just one piece of the ecosystem. As I mentioned, you have your app. Your app needs to also be highly available. Okay, and that should also be considered in the design. Okay. Now, the second point here is the environment is not highly available, and I'm not just talking about the ecosystem that connects to the database. Okay, because again, what good is a database that can be failed over within a couple of seconds if the application connecting to the database isn't highly available? Okay. The second part here is the environment, and what I mean by environment is that we're looking at, and I already started pointing out a couple of these things, like availability groups is sitting on top of a failover cluster. Your failover cluster sits on top of Windows Server. Windows Server sits on top of either a virtual machine or a physical machine. And your physical machines are sitting on top of other hardware and are dependent on other hardware, like redundant hardware for your hard drives, redundant hardware for your power supplies, redundant hardware for your network switches, and all of that. But again, the way I look at it, they're still interconnected. But there are things within the environment that affect your high availability solution. One example of this, I've learned the hard way when I was working as a data center engineer. And back then, we were managing like SQL Server 2000 failover clustered instances. So we have a 2-node failover clustered instance, and part of the management is installing updates, security patches. So part of the patching best practice is you start off with a standby node, install the patches, and when everything's fine, reboot. At this point, your databases are still up and running because you haven't done a failover. I've installed the patches on the primary node, and I'm ready to failover. Okay? I was expecting the failover cluster to do its work, because that's what it's designed for, handling automatic failover. I rebooted the primary node, and I expected that the failover cluster will move the workloads, in this case, the SQL Server databases and the failover clustered instances, on the former standby node, which is supposed to take over the role of the primary node. Unfortunately, 5 minutes later, I'm not getting anything. And then my monitoring tool starts sending me alerts and notifications. It turned out that because we schedule our patching patching and maintenance window over the weekend, it turned out that one of the operations engineers also, and this is something that I didn't really plan and I didn't anticipate, one of the engineers, operational engineers, also rebooted the domain controllers all at the same time. Now, we had like 3 domain controllers within one environment for redundancy. Again, the environment attached and the dependent environment is highly available. We designed it to be that way, but unfortunately, the operational engineer decided to reboot all of the domain controllers at the same time. So back then, domain controllers sitting on hardwares, and I think we were working with IBM blades that were daisy chained and would take an average of 40 minutes to reboot. Yeah, it took about 40 minutes for the domain controller to get rebooted, and because the failover cluster could not authenticate to any available domain controller, it stayed offline until the domain controllers are all up and running. I mean, despite the fact that we have 3 domain controllers in the environment, somebody decided to reboot all of those domain controllers at the same time. Therefore, I got nothing to authenticate to. And that's one of the reasons why it took longer. In fact, I could not failover my failover clustered instance to the other node, even though both of the nodes are functioning. Even though the failover cluster is functioning, but the fact that on failover, a failover clustered instance's virtual computer object has to authenticate to Active Directory, and Active Directory is not highly available in this case, it couldn't failover. Okay? And these are dependent components outside of the failover cluster itself that it is dependent on. Active Directory is one, DNS is one, networking is one. I've enumerated some of those components where the failover cluster is dependent. So you need to have those highly available. And we're not just talking about redundant power supplies, redundant power distribution units, and redundant switches, but things outside of the failover cluster in and of itself that it is dependent on. A couple of the outages interestingly though, with AWS and Azure, and now it's Cloudflare. Now, with all of these outages hitting the news, you kind of wonder, wait a second, how do we provide redundancy and high availability on other components that my high availability solution depend on? In the same way, that case that I experienced, that was a really good learning experience for me. Good thing it was during a maintenance window, and 40 minutes was within our maintenance window. And so that's when I learned you have to make the environment that your high availability solution depends on to also be highly available. Okay? Even in the world of virtual machines, I've seen cases of VM admins configuring virtual machines that are part of a failover cluster do not have anti-affinity rules, where the VMs should never be in the same physical host at the same time. Well, your VMs are dependent on a physical machine, and so that physical machine is no longer highly available when both VMs, or all of the VMs for the failover cluster, are there, which means your environment is not highly available. So again, dependent components of your high availability solution should also be highly available. One customer that I worked with back in 2019, they were building multiple failover clusters in the environment, and they wanted to provide a file share witness running on their Windows Server failover cluster. So it's a dedicated failover cluster that is for the file share witness. And the thing is, if that failover cluster becomes unavailable, you might be thinking, wait a second, it's highly available. True, it's already highly available because the file share witness is running on top of a failover cluster. But what happens if that failover cluster becomes unavailable. Okay? It becomes a single point of failure for every single Windows Server failover cluster that's using this cluster as the host for the file share witness. So you have to think of the entire environment, not just the databases, but the entire environment. Of course, to the previous point, the application as well should be highly available, not just the database. So avoiding single points of failure, making sure that the environment that your failover cluster, or in this case, the high availability solution is dependent on, should also be highly available. Okay. Third one is the assumption versus requirements. What do I mean by assumption versus requirements? When you build, or when somebody builds or designs a high availability solution, there are several assumptions. Assumptions like zero downtime and zero data loss. And those assumptions become the foundation, or become the source of information for making decisions on which feature to use, which technology to use, versus requirements. Okay, what do I mean by requirements? Well, recovery point objectives, recovery time objectives, and service level agreements. Okay, difference between we assume versus this is the fact. Okay, the one customer that I worked on a couple of years ago, I was doing an assessment of their entire availability group solution. They're more like a software as a service business, and they got multi-tenancy. So they have different customers depending on their software, and it's becoming more and more expensive to maintain a database. Because they've got enterprise edition licensing, they've got top of the line NVMe with SSD combination for their storage subsystem. No spinning disks, nothing, no tiered storage. It's all flash, SSDs, NVMe combination. And I asked them, so why did you design this system in the first place? Well, because we want zero downtime, and we want zero data loss for our customers. And I asked them, so is that what you communicated to your customer? Like, is that when you sign new customers up, and when you onboard new customers, is that what you tell them? There was silence in the conversation because they really never thought of that. Realizing, of course, that their business is supporting restaurants. And you know how it is with restaurants. They're pretty busy during normal, operational hours. But sometimes restaurants close. Sometimes, of course, there's no such thing as 24-hour restaurant. Diners are running. There are some diners that run 24/7, but restaurants, not really. Okay, but they built their software and they built the entire solution based on assumption, instead of asking customers what is their requirement, instead of building the entire infrastructure based on customer requirements. And keep in mind, they are the ones providing the platform to the customer. Okay, so same thing. Instead of making assumptions like we want zero downtime or zero data loss, you have to be clear about the business requirements and not just make assumptions. Because when we start with the assumption that we need zero downtime and zero data loss, we're already putting ourselves in the corner and assuming that we can actually achieve that. I mean, given the previous outages from the big cloud providers like AWS, Azure, and Cloudflare, there is no such thing as zero downtime and zero data loss. There isn't. So you have to be very, very clear about what the real requirements are. Because chances are, if you make those assumptions, like again, zero downtime and zero data loss, you are going to put in a ton of money, a ton of effort, a ton of resources, and a ton of manpower just by designing it and then maintaining it. Plus the fact that nobody actually can go against physics. So you gotta be clear, is this an assumption or is this a requirement? Okay, that specific customer, they've already built their HA solution for their databases, even for the app layer, where they got multiple redundant switches and load balancers. But I asked them, okay, so you're serving this specific industry, you're serving this specific time zone, you're not spanning multiple time zones, just one time zone. So you're telling me you've over-designed, over-provisioned, and over-implemented something that your customers actually don't need? And that's one of the reasons why the initial design is actually broken, which means you may have to re-architect it to prevent those issues from happening. In fact, that particular customer, one of the reasons why they brought me in was because they're having performance issues despite the fact that they have top-of-the-line hardware, top-of-the-line storage, and very expensive SQL Server licensing for their databases, and they're having a ton of performance problems, and they could not perform maintenance. Well, again, they boxed themselves in the corner, not realizing that their customers don't actually need 24/7 by 365. Okay, so that's one of the reasons why their initial design was broken to a point where we started looking at breaking away from that kind of design, which means they no longer needed Enterprise Edition. Man, I feel for them because they've already spent money on licensing and now they have to downgrade. But of course, there are more important design challenges that they had in addition to the high availability requirements. So again, assumption versus requirements. You got to be clear on the business requirements like recovery point, recovery time, and SLA. Clear definition of SLA, meaning what you promised your customer or the business users versus what you want to build. And I don't know, maybe it's just me. I would rather not overspend and over provision on something that I don't really need, and just plan for it with a little bit room for growth. But that's it, because again, that's money, of course, not my money, but that's time, money, resources, and manpower that you're putting into a high availability solution that is probably over-engineered. Okay, so again, assumption versus requirements. Those are the things that you have to ask yourself. When you're encountering issues after issues for your existing high availability solution, you got to ask yourself, is the design just focusing on a database and not the entire ecosystem? Meaning the apps that connect to the database, or even the network layer where the apps connect to, is it highly available? What about the environment? The environment that your high availability solution depend on, like in the case of that customer, or me in that case, where my failover clusters depend on Active Directory. And then all of a sudden your Active Directory is not highly available, right? Or you're running virtual machines, and your virtual machines are not configured with anti-affinity. So they can all of your VMs for the failover cluster would end up in the same physical host. Then you end up with a system that has a single point of failure. And of course, assumption versus requirements. Making sure that you're not over-provisioning just because you've made an assumption versus collecting information and gathering information so that you can properly define your business requirements. Talking about recovery point objective, recovery time objective, and service level agreements. Okay? You don't want to over provision and over engineer because that's expensive. That is about it for this week's episode of the Practical SQL Server HA show. Tune in again next time for another episode. And if you have any questions, feel free. Some people were posting comments on, regardless of wherever you are watching this, whether it's on YouTube, I think it's also streaming on Facebook, on LinkedIn. There was one comment on one of my YouTube posts asking if I can do a a video on network dependencies whenever you're designing high availability and disaster recovery solutions. Meaning that, fundamental ideas and knowledge that you need to learn whenever you're building a high availability or even supporting a high availability solution. So appreciate that. Really, really thank you. That's about it again for this week's episode of the Practical SQL Server HA show. Tune in again next week for another episode. And if you have any questions, or maybe that's you, where you're wondering, why is my high availability solution not highly available? Maybe we need to reevaluate your design and see if it actually makes sense for what you need. Use that link on the screen, schedule a strategy session, and let's have that conversation. This link will lead you to my calendar page where you can pick and choose the time that works for you. In the strategy session, we're going to focus on two things. One, get really clear on what the goal you're trying to accomplish. And it's more than just, I want to build an HA solution, I want to build a DR solution. We'll get very, very, very specific and very clear, because I don't want you to build a high availability and or disaster recovery solution if you're not really sure what it's for. Okay, so we're going to get clear on what the real goal is and the next step, meaning once we're clear on what your goal is, you're going to have a step-by-step strategy on what to do next. Because what's the point of defining your problems if you're not very clear on the problem, if you're not going to solve it? Okay, so again, use that link on the screen, schedule a strategy session. Looking forward to having that conversation. If I can help, I will. If not, I will steer you in the direction that will help serve you best. Again, that's about it for this week's episode of the Practical SQL Server HA show. Keep your comments, your feedback coming. Really appreciate those. And I will incorporate those in future videos. Enjoy the rest of your weekend. I'll see you again in the next episode.